All of you welcome in the basic panel Sem 5. We will study mathematics paper 2 DSE. Myself Dr. D. N. Varade. The paper mathematics paper 4 special relativity. This is of 60 marks. There are 4 units. Unit 1 Lorentz transformations. Unit 2 Lorentz transformations. Unit 3 relativistic mechanics. Unit 4 space-time structure. Now we start first unit 1 Lorentz transformations. We'll see the definition of space. Absolute space in its own nature without relation to anything external remains always similar and immovable. Then space, then the definition of time. Absolute true and mathematical time of itself from its own nature flows equably without relation to anything external. Then we see the Newton's 3 laws of motion. Newton's laws of motion. First law, a body continues in a state of rest continues in its state of rest or of uniform motion unless it is acted upon by external forces by external forces. Then Newton's second law of motion. It is about the momentum, the rate of change of momentum is proportional to the impressed force and it is in the direction of force. Then the Newton's third law of motion. To every action there is equal and opposite reaction. These are the 3 Newton's laws of motion. The first law, a body continues in a state of rest or of uniform motion unless it is acted upon by external forces. The second law, the rate of change of momentum is proportional to the impressed force and it is in the direction of force. To every action, third law, to every action there is equal and opposite reaction. Then next topic we see the inertial system. The inertial system, first we see the definition of inertial system. The reference frame in which the Newton's first law of motion is valid is called as the inertial system. The reference frame, or we can say a reference system, or reference frame in which Newton's first law of motion is valid is called as inertial system. If the body is not under the influence of any force, then the motion can be explained by Newton's second law of motion, that is F equal to ddt of m into v, where F is the force acting on the particle, m is the mass of the particle, and v is the velocity of the particle. Now here the mass is the inertia, measure of inertia, it is supposed to be constant. Therefore we have F equal to m is taken outside the derivative, m into ddt of v, because m is constant. Therefore we have m into dv by dt, and we know that dv by dt is nothing but acceleration, that is rate of change of velocity with respect to time is the acceleration. A equal to acceleration equal to dv by dt. Therefore we have F equal to m into a. This F and A are the vector quantities, therefore we make their bold. F is the bold, A is bold, these are vector quantities. Now if F equal to 0, then we have A equal to 0, if r is the position vector of the particle, if r is the position vector of the particle in the reference system, then we have velocity v equal to dr by dt and acceleration a equal to d square r by dt square. Now if a equal to 0, then a equal to 0, therefore d square r by dt square equal to 0. Integrating this equation with respect to t, we have dr by dt equal to constant equal to a. Again integrating this equation, we have integration of dr equal to a into integration of dt. Therefore, integration of dr r at plus b now this equation 3 represents a straight line. Therefore, I say that a particle moves in a straight line with constant velocity, which is equation of straight line. Therefore, I say that the particle moves in a straight line with constant velocity. With constant velocity. There is question in the examination like this. You can write in your problem example. Show that in a reference system, a particle moves in a straight line with constant velocity. The question can be asked for 6 marks. Also, there is define the reference system. So you have to give the definition of reference system. Inertial system, where the Newton's first law of motion is valid, is called as inertial system. Then next I see the definition of event. Definition of event: anything that happens is called an event. It is analogous to a point in the geometry. It is analogous, that is similar. It is analogous to a point in geometry. In the Newtonian mechanics, the event can be expressed in terms of x, y, z3, where the first 3 coordinates x, y, z are the space coordinates of the event and t is the time at which it occurs. In Newtonian mechanics. In Newtonian mechanics, the event can be expressed by xyzt, where the first three coordinates xyz are the space coordinates, and t is the time at which it occurs, space coordinates of event, and t is the time at which it occurs. Now, which is the definition of event? Anything that happens is called event. It is analogous to a point in a geometry. In Newtonian mechanics, Nm, the event can be expressed by xyzt, where the first three coordinates xyz are the space coordinates of the event, and t is the time at which it occurs. Then next we see the Galilean transformations. The Galilean transformations, it is important. There is a question: obtain the Galilean transformations. And see the who obtain the Galilean transformations. Consider two reference systems, S and S dash, where the system S dash is moving with velocity v, S dash is moving with velocity v with respect to reference system S. Let their origins coincide at time t equal to 0, t equal to 0, t dash equal to 0. Let their origins means the origins of two reference system S and S dash coincide at t equal to 0, t dash equal to 0. Any single event in the system can be described by P of RT, P dash of R dash T dash. where R is the vector x, y, z. Also there is time coordinate x, y, z, t. Now this is the figure for this. Draw the figure. Draw this triangle. This is O dash, and this is P. P is given by P of RT. This is R vector. This is R dash. Direction is like this. Now this velocity V, where O dash is moving with velocity V along the common x dash axis. Then we use the here triangle law of addition. By triangle law of addition, we get from the triangle R dash equal to R minus O dash, that is R dash equal to R minus VT by triangle law of addition. By triangle law of addition, we get R dash equal to R minus O dash, that is R dash equal to R minus VT, where V is the velocity. Now here this R dash, these are the two vectors. These are denoted by bold. This V is also vector. Therefore, these are denoted by bold letters. In classical physics, the time is expressed independently of any particular reference system. In classical physics, the time can be expressed independently of any particular reference system. Therefore, we have T dash equal to T. Now from this transformation 2, we say that the time is same in all inertial systems. The time t is in the system S, the time t dash is in the reference system S dash. From this transformation 2, we say that the time is same in all inertial systems. Here, the transformations 1 and 2 are called general Galilean transformations. The transformations 1 and 2 are called general Galilean transformations. General Galilean general Galilean transformations. Then we obtain the special Galilean transformations, simple Galilean transformations. Now for this, we let r equal to x, y, z, and we have r dash equal to x dash, y dash, z dash. Now in the figure, the O dash moves in the direction of common x dash axis with velocity v. Therefore we have if O dash moves along common x dash axis with velocity v, then velocity v equal to v0, 0. Now we put the value of this v in the transformation 1. Therefore, the transformation 1 becomes r dash equal to r minus vt. Now we put the value of r dash, r and v. Therefore, x dash, y dash, z dash. Value of r is x, y, z minus velocity v0, 0 t. Therefore, we get x, y, z minus vt, 0 into t, 0 into t, therefore 0, 0. Therefore, x minus vt, y minus 0, z minus 0. In the left hand side, there is x, y, z. Therefore, x dash, y dash, z dash equal to x minus vt, y, z. Then equating the two sides, equating the corresponding quantities, we get x dash equal to x minus vt, y dash equal to y, and z dash equal to z. Equation 3. Now in the transformations 1 and 3 are called the simple Galilean transformations, the transformations 1 and 3 are called simple Galilean transformations. Then we see the inverse transformations of the transformations 1 and 3. The inverse transformations are obtained by changing the plus sign to minus sign to plus sign, x dash to x, x to x dash, t to t dash, y dash to y, z dash to z. The inverse transformations of one and 3 are the inverse transformations of 1, 2 and 3 are, the first equation is r dash equal to r minus vt, the second equal to t dash equal to t, and third equation is the inverse transformation of this r dash equal to r minus vt. R dash is replaced by r is replaced by r dash, then minus sign there is take their plus sign, v is constant as it is, and t is replaced by t dash. Therefore r equal to r dash plus vt dash. Then second transformation, t dash is replaced by t is replaced by t dash. Therefore t equal to t dash. Similarly for the equation 3, the inverse transformations of equation 3 are given by x dash equal to x minus vt. We write x equal to x dash plus vt dash, y equal to y dash, and z equal to z dash. These are the required Galilean transformations. Now, today we stop here. It is sufficient for today.